I wanted to put together this little video clip for you just to go over a quick review what we talked about today. There'll be two parts to it. I'll do a couple of the stoichiometry problems, then my part two will be going over the reaction types. So here's part one. This was your second problem, and it read, determine the theoretical yield of water that can be formed from 10 grams of hydrogen and 100 grams of oxygen. And the question is also, what is the limiting reagent? Well, theoretical yield and limiting reagent are going to go hand in hand because the limiting reagent determines the theoretical yield. So in a situation here, whenever you have values given to you about one part of a reaction, and I want you to determine something about another part, you need a balanced chemical equation. So we have 2 moles of hydrogen plus 1 mole of oxygen will yield 2 moles of water. Next, I teach you take the information out of the problem you know. First of all, you know in this problem you were given 10 grams of hydrogen and 100 grams of oxygen. Now, you can actually make this step now if you wanted to convert them both to moles. And so I do that by way of molar mass. We get molar mass from the periodic table. H2 weighs in at 2.02 grams, gives me 4.94 moles of hydrogen. And my O2, 32.00 grams, gives me 3.1 moles of oxygen. Now, if I do a ratio based upon a mole-mole ratio based upon the balanced chemical equation, I see that for every 1 mole of oxygen, I need 2 moles of hydrogen. So if I have 1 mole of oxygen, I need 2 moles of hydrogen. If I have 2 moles of oxygen, then I need 4 moles of hydrogen. Well, I have 3.1 moles of oxygen, therefore I should have 6.2 moles of hydrogen. I do not have that. Therefore, my hydrogen is my limiting reagent. Knowing that, then I could take my moles of my hydrogen will be the one to determine the theoretical yield of my water. And I will take start with moles of hydrogen, set up my mole to mole ratio to get to, it's a 2 moles of hydrogen to every 2 moles of water, which is simplified down to a 1-to-1 ratio. And then I have the molar mass of my water equals 1 mole equals 18.02 grams of water. And there is my theoretical yield, 89.2 grams of water. That's my theoretical yield. You could do it that way, or you could just take both of your reactants and run them both through the roadmap. If I took my 3.1 moles of oxygen and ran that through the roadmap, I would end up seeing that my zero point 0.3 or my 3.1 moles of oxygen would be able to produce 112.6 grams of water. If you did it this way, you then compare your yields, and you always go with the smaller one, which would be 89.2, because you will get to 89.2 grams of water, but you'll never make it to 112. Why? Well, because the hydrogen, your limiting reagent, will run out. A second example is that of dealing with, I want to know how many grams of aluminum oxide can be formed from 100 grams of aluminum and 100 grams of oxygen. Again, you need a balanced chemical equation. So you have 4 moles of aluminum plus 3 moles of oxygen yields 2 moles of aluminum oxide. Now let me show you another technique. I could just skip doing the mole to mole ratio, I could just skip changing my mass to moles, and I could just start out and run both of my reactants. Starting with grams, I could run them both all the way through the roadmap. If I did that with my 100 grams of oxygen and the molar mass of, 100 grams of aluminum, excuse me, I do the molar mass of aluminum, gets me the moles of aluminum. And I said by mole to mole ratio, I have 4 moles of aluminum to every 2 moles of aluminum oxide. That could be simplified down to a 1 to 2. Then I have the molar mass of aluminum oxide tells me that my 100 grams of aluminum would be able to produce 189.0 grams of aluminum oxide. If I did the same thing with my oxygen would tell me I would be able to produce 212.4 grams of aluminum oxide. I always go with the lower of the two values. That's my theoretical yield. Because the fact is, you'll get up to 189, but you'll never get up to 212 grams. Why? Because your limiting reagent, aluminum, will run out. Or you could take the other technique like we've done before, and I could just change my mass to moles and then do a mole to mole ratio. This will take a little more work, but I have for every 4 moles of aluminum, I would have 3 moles of oxygen, and you could do a comparison there and find out who would be your limiting reagent that way. These are two techniques. Hopefully they're, again, kind of showing you a broad perspective of this, but it really comes down to what you prefer, because all of them will take you about the same amount of time.